All right, we're getting started a little late today, had a fire drill, and so a little bit of a shorter YouTube lesson. We did already go over, just before the fire drill, we went over the worksheet that we finished up yesterday. I was able to give some candy to some students who had all correct answers. So if you got all the correct answers, maybe you can talk to your mom into giving you some candy. Anyway, the answers to the bottom section were 38.89, 10,168.074. There were your two addition problems. You had three subtraction problems, 713.89 the first answer, 20.69 the next answer, and 0.2264 was the third answer to the subtraction problems. For the multiplication, we needed to keep track of how many total decimal places. We do need 5 decimal places in the next to last problem. 0.55226 the answer. And the final answer needed 6 decimal places. Initially, you get 0.000120, or we can knock off the last 0 and just say 0.00012. Several students in here were perfect. Some just missed 1. A few others just missed 2. Were there any questions? Do we need to see any of those worked out, students in here? Any questions? Any of those problems we need to see worked? All right, go ahead and set that aside then, if you would, please. And turn your textbooks to page 4. Turn your textbooks to page number 4. Want to talk now, we've worked on addition, subtraction, multiplication. Class, what comes next? Division. Yes, so we're going to talk about everybody's favorite process. I am going to spend 2 days on division, okay? I understand that for many students this is a struggle. Please be still. This is a struggling concept for you. So I want to try to help you overcome those difficulties. I don't want you to be scared by long division. I want you to have confidence knowing how to handle it. But it's imperative that you focus carefully, pay attention as we're going over this, and if you're not sure about something, ask a question, all right? But some terminology for you to know. First of all, there on page 4, in division problems, typically we will use a division house. The value in the division house is called the dividend. The dividend, you see that term there. The term that's doing the division is called the divisor. And the answer, make sure you note this, and somebody answered this the other day, is called, class, the quotient.
Wow.
The quotient. Now, there are other ways you'll see division as well. You'll sometimes see this symbol. The first number is the dividend, meaning the first number is what would go in the house. The divisor is the second number. And of course, the answer is still the quotient. You may also see division another way, with a fraction bar. Now, you do this, by the way, when you take improper fractions, right, and turn them into mixed numbers. We'll talk about that a little later on. But the top number is the dividend. The lower number is the divisor. And once again, the answer is the quotient. Okay? This is typically the way we'll see them for now, however. But you'd want to make sure you knew how to set them up if you were to see something just a little bit different. If you would, on the back side of your handout from yesterday, that homework handout, classwork really more than anything, we got most of that homework, quote unquote, done in class. But if you would, go and get that handout out and write this problem down. 2,628. We're going to divide it by 6. 2,628. We're going to divide it by 6. Go and copy that problem down. Work it along with me. Division requires a few more steps than other processes in mathematics. And that's one of the reasons why it gives students fits. You've got to have the process memorized, the order of the steps memorized. And you've learned these, most of you, since 3rd grade, haven't you? We divide, multiply, subtract, compare, bring down. How many remember those steps from your 3rd, 4th, 5th, 6th grade days? Let's say them together, class. Divide, multiply, subtract, compare, bring down. And when you're dividing by a single digit, these are the only steps that you need. When we divide, we're going to ask ourselves, how many times does 6 go into 2? Can 6 go into 2, class?
No.
It's not big enough. If that happens, you're going to extend to a second digit, and that's quite all right. So how many times does 6 go into 26, class? 4 times. And we're going to line up the 4 with the back end of the 2 digits. Now, if this had been like an 8 right here, 6 was an 8 one time, we put it directly above the 8. All right, and then we multiply it because 4 times 6, class, is 24. So there's our multiplication step, and we're going to put the 24 right below the 26 because our next step, class, is to subtract. Make sure you're doing this with me on your own paper. We're going to subtract 26 minus 24, or really 6 minus 4 class equals 2. Of course, 2 minus 2 is nothing. And we're going to then compare. We're going to make sure that the 2 is smaller than the 6. And it is. And then we come to our next step, which is to bring down. We're going to bring down the 2. And then we're going to go all the way back up to the top and start over again. We're now going to ask ourselves, how many times does 6 go into the number that's down here? How many times does 6 go into 22 class?
3.
Only 3 times. Because multiply, 3 times 6 is 18. And we put it down here because we're going to subtract. And we may need to do a little bit of borrowing if we can't do it in our head. 12 minus 8 is 4. Of course, 1 minus 1 is nothing. We compare to make sure 4 is smaller than 6, and it is. And then finally, class, we will bring down the 8. And then we go all the way back again, class. Once again, we divide, which means you ask yourself, water bottles off your desk, how many times does 6 go into 48? 8 times. And it goes in evenly, right? I'm okay if you know, well, that's exactly 48. You don't need to write the 48, the minus sign, and the 0 necessarily. You could just stop, and I know it's 438, and we're done with the problem. Do we remember doing long division? All right, let's write another problem on your paper now. 756, we're going to divide it by 42. 756, we're going to divide it by 42. In this particular problem, I don't know my 42 times tables. Agreed? Like I know 1 times 42 is 42, and most of us could figure out that 2 times 42 is 84, other way around. But trying to figure out more, like, we don't know our 42 times tables, that's silly. Nobody wants you to know your 42 times tables, that's the good news. When you do the division step, only focus on the first digit. All I care about is the 4. And all I care about here is that first digit, if it's big enough. How many times does 4 go into 7? That's all I'm going to ask, because I know my 4 times tables, right? How many times does 4 go into 7, class? Once. Now notice, I've got 2 digits here, so I'm going to put the 1 right here. So that when I multiply in my next step, and of course we know 1 times 42, class. Class, 1 times 42? 42, there we go, okay. All right, we're going to put it down here, and that way everything lines up neatly. So however many digits we have here, that's how many digits over we count to put our answer there. And then, of course, we've divided. We said 4 goes into 7 once. We've multiplied 1 times 42. Then we're going to subtract. Thank you, Bryson. And when we subtract, 5 minus 2, class? 3. 7 minus 4? 3. We're going to compare to Corey. 33 is smaller than 42. It becomes a little more important to do that when we have a multi-digit divisor. And then we're going to bring down the 6. And we go back to the beginning again. And once again, class, we're only dividing with that first digit. How many times does 4 go into 3? Can 4 go into 3? No. So we do what we did last time. We add another digit with it. How many times does 4 go into 33? 8 times, because 8 times 4 would be 32, right? So we put the 8. And then we multiply. Now, I would encourage you to multiply right here on the problem. But some of you may say, Mr. Esky, I really need to do 42 times 8 off to the side. That's fine. You can. But I think we could do it just fine this way. Watch. Follow along with me. If we did it right here, I'd start by saying, what's 8 times 2, right? Can't I do 8 times 2 here as well? What's 8 times 2, class? 16. And I can write the 6 and carry the 1 just as well as I could say write the 6, carry the 1 there, can't I? I could do that. And then I would say 8 times 4 plus 1. 33. Just as well as I can say, okay, 8 times 4 is 32 plus 1 is 33. I mean, if I can do it off to the side, why couldn't I do it here as well? But if you need to, if you're just like, my brain just doesn't tick like that, it's not a sin to do that off to the side. Of course, then we would subtract, and of course, we'd get 0, and there's our answer. Do you understand the concept, class, of only using the first digit for the division? Don't try to say how many, I mean, you all know 42 goes into 75 once. We can figure that out. But how many times does 42 go into 336? I don't want to have to think about that. But how many times does 4 go into 33? That's no problem. Use just that first digit. Does that make sense? One more to write down. I'll give you a chance to we'll work some other stuff. Write this down. 8,832. 8,832, and we're going to divide it by 384. And some of you might have been thinking, when I wrote the 5 steps of division, you might have been thinking, Mr. Nadasky, I felt like there's 6 steps of division now. Like there were 5 steps when we were in 3rd grade, but there became 6 steps. Does anyone remember, it's kind of a preliminary first step that we do in long division. We represent it with the letter E. Does anyone remember what it stood for?
Estimate?
Estimate. Here's the deal. In the number 42, the 4 doesn't mean 4, class. The 4 really means 40. We think of it as a 4 for practice, but it really means 40. Now question, is 42 much different than 40? No. It's pretty similar, isn't it? Right here, what does this 3 mean, class?
300.
300. Is 300 very different from 384?
Yes.
Yeah. If you owed somebody $300 or $384, that does start to make a difference. Remember when we talked about rounding? I said if a digit is 5 or bigger, it bumps it up. The estimator says this. I know this is a 3, but look, pay attention, look right behind the 3. That's a big old 8, isn't it? That's going to bump it up to a 4. That's my estimator. So when I do my division step, I'm not going to say how many times does 3 go into something. I'm going to ask myself how many times does 4 go into something. Because that 8 really tells me I don't want a 3. I want to round it up. Does that make sense? You're going to have a lot more accurate results if you'll bump it up when, again, this is 5 or bigger, bump it up. All right, so let's try this division here. The division step is going to be based off of the 4. How many times does 4 go into 8? Class? 2 times. Now watch. 1, 2, 3 digits. That's where the 2 goes. Make sense? And now we go through our next step, which is to multiply. Again, if you need to multiply 384 times 2 off to the side, that is not a sin. But I think we can do it the other way. I think we can, just as well as we say 2 times 4, I think we say, what's 2 times 4, class? 8. Line it up. What's 2 times 8? 16. We write the 6, carry the 1 off to the side. What's 2 times 3 plus 1? 7. And we're going to then subtract the 716. You're doing this on your paper with me. We'll, of course, do a little bit of borrowing here. 13 minus 8, 5. 7 minus 6, 1. 8 minus 7, 1. We compare to make sure that 115 is smaller than 384. And then we need to, class, bring down the 2. Now we go back to the beginning again, which is to use that estimator to divide. Again, these steps are kind of connected as one. We're going to say, how many times does 4 go into, not 1, because 4 can't go into 1. How many times does 4 go into 11, class?
2.
Almost 3, doesn't it? I mean, really close. And it's not quite a 4. Let's try the 3. Let's just see if it works. Because if that were just a 12, and it would round up to a 12, by the way, if you wanted to carry the rounding that far. Let's try 3. 3 times 4.
12.
Write the 2, carry the 1. 3 times 8 plus 1. 25. Write the 5, carry the 2. 3 times 3 plus 2. 11. Hey, it worked out perfectly. But you say, Mr. Dasky, you did some mind games there. You were like, well, it's almost, and maybe. I don't know if I could handle that. I'm only in 7th grade. Well, okay, let's suppose you take it very literally. And let's suppose you say, 4 goes into 11 twice, Mr. Daddy. It does not go in 3 times. Okay, then try the 2. There is some trial and error, by the way, to division. That's okay, head off hand. There's some trial and error too. You try something, doesn't quite work. Well, we know already what 2 times 384 is, don't we? Because it's sitting right there. We're not going to waste our time re-multiplying the 2 when I know it's a 7, 6, 8. And if we do our subtraction with a little bit of borrowing, we get, let's see here, 384. When you do your compare step, is 384 smaller than 384, class? No, it's exactly big enough that it could have gone in 1 more time. That tells you, oops, it wasn't a 2, it should have been a 3. And by the way, since it worked out so perfectly, I ain't even going to waste my time redoing it. I'm just going to circle 23. So even if you're a little off with the estimator, you can recover very quickly and easily. The compare step bails you out there. Questions on these first 3 problems that I've shown you largely? Any questions on those? All right, let me give you another handout because your book doesn't have a lot of problems here. So let's take another handout. As always, if you're watching on YouTube, you'll find the handout in the description of the video, or a link to it at least. Again, if you need to pause the video while you print that out, that's perfectly acceptable. Let's go ahead and take a look at the first problem on the handout. We are going to work together here as a class. So try to stay with me on the problem. Now, if you want to finish the problem before I do, that's okay. But we're going to work them together as a class. But I'm going to have you do most of the talking now. So let's start with that first problem. I'll copy it on the board. You've got it on your paper there. 32,616 is getting divided by 453. Since it's more than one digit, we need to use the estimator for the division. Should I roll with a 4 or should I bump it up to a 5? That's the first question. Luciana, what do you want to do here?
Bump it up to 5.
The 5, yeah, just barely, right? It just barely bumps it up to 5. But let's play with the 5 here. And we're going to ask ourselves, how many times does 5 go into?
32.
Good, not 3 because it's not big enough, but 32. How many times does 5 go into 32?
6.
6 times. Now watch, class, watch very carefully. How many digits do I have here, class? 3. But remember, this is collectively 1. We're looking at this as all one thing. So 1, 2, 3. When she says 5 is into 32 6 times, I'm going to put it here. Do you understand how to count the digits? If you had to use 2 digits for the division step, pair them up. This is 1, 2, 3. That's where the 6 goes. All right, so that's the division step. Next thing I need to do, Bryson, is to multiply. I'm going to try it this way. I think we can follow along here. 6 times 3.
18.
Bryson, 6 times 5 plus 1.
31.
6 times 4 plus 3.
27.
27. That doesn't look very big. I'm not sure if we made it or not, but let's just try it out. Let's do a little bit of borrowing here.
3. 4.
We're going to do a little more borrowing here.
5.
That's where the compare step comes in. Did I make it, class? No. In other words, I could have gotten another one out. I just didn't know that, right? So instead of a 6, class, it tells me we should have used a...
5.
This is too big. There's too much. So this is not big enough. Right? Okay, let me put it this way. How many have heard of the IRS? You know what the IRS is? They take taxes, right? And they tax and they tax and they try to get all the money they can from you to run the government, which overspends even more than what we take in. Well, let's suppose you're a greedy IRS agent and you can think of another, or maybe go back to Robin Hood. You know Robin Hood? Okay, maybe that's an even better example because the IRS isn't quite as corrupt as, you know, Prince John. Prince John, that's what his name. Prince John and the sheriff. Y'all know what I'm talking about? Robin Hood? Okay. So imagine you're like Prince John. You're trying to get everything you can. All right? I only got 6, but look, this person still has too much money. I could get a 7th from this person, okay? So there's too much left down here, so we're going to go with a 7. I told you there's some trial and error. There you see some of it. 5 actually goes into 32 6 times, but again, it was a rounded 5 anyway. We end up going with a 7 here. Let's try it again, and Sam, help me. Now we're going to multiply 7. 7 times 3.
21.
7 times 5 plus 2. 7 times 4 plus 3. 28 plus 3. 29, 30. 31. All right, 7 times 4 is 28 plus the 3 more gives us a 31. All right, let's go and do our subtraction here. Page 1 minus the 1.
0.
We're going to do a little borrowing here. 16 minus 7.
8.
Careful, 9. 1 minus 1, of course, is
0.
0, and 3 minus 3 is also
0.
0. Okay, so we just get a 90. Next thing we need to do, of course, is to, Jalen. We've got a 90. We need to, no, we just multiply. That's how we got the 3171. Then we subtracted, so now we need to compare. Is 90 smaller?
Yeah.
It's a whole lot smaller, so we're good. That's happy. So then, Jalen, since we're smaller, we can go ahead and
Bring down.
bring down. We're going to bring down the 6. Then we go back to the beginning and we use our estimator to divide. Now, how many times does 5 go into 9, Corey?
1.
Only once. But is it really a 5? We kind of rounded that. And 5 even would almost go into 9 how many times? Almost twice, right? Almost. I mean, so I'm going to try the 2 here. And we'll use the 2 to multiply. When we multiply the 2, Michael, 2 times 3?
Oh, 6.
Stay with me. 2 times 5.
2.
Carry the 1. 2 times 4 plus 1? 9. And it works out. Great. But do you see some of the trial and error? I'll give you a strategy tip, folks. when the second digit is a 5, 6, it's just barely big enough to bump it up, a lot of times you're gonna run into that. But if you went with the 4, you try something that was too big, right? How many times does 4 go into 32, class?
8.
That's too big. So if you try the 4, you got 8, which is too big. If you use the estimator, it's 6, which is too small. Where was the actual number? Right in between them, wasn't it? Not the 8 or the 6, but the 7. So sometimes you can figure out patterns like that, cheat the system. Let's do the next one together. You've got it on your paper there already, 771,951 being divided by 87. What's my estimator that I'm going to use this time, Kirsten?
8.
Well,
7.
the point is the 7's big enough to bump the 8 to what?
90.
Let's go with a 9 here, right? Now, technically its value would be a 90, but I'm just going to think of a 9 because the 7 bumps the 8 up, and it's a good size number. So then we're going to ask ourselves, Kirsten, how many times does the 9, our estimator, go into?
7.
Can 9 go into 7?
No.
No, so we're going to have to add another digit with it and say, how many times does 9 go into?
77.
77. How many times does 9 go into 77, Kirsten? Go with those 9 times tables. Helper class? 8. So we need to make sure we're working on those times tables because 9 times 8 is what class?
72.
72. So that would fit under the 77. Now, how many digits do we need to count over, class?
2.
2. But remember, this counts as 1. 1, 2. So when we say 9 goes into 77 8 times, we're going to line it up over the 1. All right, so there's our estimate and divide step. Now we're ready, Ben, to?
Subtract.
Not yet. We've divided. Multiply. Let's go ahead and multiply. Ben, there's nothing to subtract yet. 8 times the 7.
56.
Carry the 5. 8 times 8 plus 5.
71.
Ooh, help, class.
69.
69. 64 is 8 times 8 plus the 5 more 69. Okay, so we've got some multiplication tables we need to shore up, it sounds like, a few of us. So we're going to go now, we're going to go ahead and subtract the values. And of course, there's some borrowing that's got to be done. 11 minus 6, Elaine.
5.
And do a little bit more borrowing. 16 minus 9.
7.
7. And 6 minus 6 is nothing. We've got to do what now that we've subtracted, class?
Compare.
Are we good, class?
Yes.
Yeah, it's pretty big, but it's not 87. So then we're ready to bring down. So we're going to bring down to 9. And we go back to the beginning again. We're going to use our estimator to divide, Griffin. Our estimator is a 9. How many times does 9 go into?
75.
75. How many times does 9 go to 75?
8.
8 again. By the way, mathematicians are?
Lazy.
We just multiplied 8 times 87, didn't we? What did we get when we multiplied 8 times 87 last time? 696. Guess what we're going to get this time? 696. I ain't going through that again. I already did that work, right? Save some time. Let's subtract a 696 here back to Luciana. 9 minus 6.
3.
And we'll do a little bit of borrowing. 15 minus 9. 6. And is 63 smaller than 87, class?
Yes.
Yes, and we'll bring down the 5. Is 8 going to work again?
No.
No.
No, 696 is too big. Well, 8 doesn't work, but that's pretty close. So maybe 7. Or you could use your estimator. How many times does 9 go into 63? And obviously, class, the answer is 7. So we're going to use 7 as our number here. Unfortunately, that means we actually have to multiply this time. And Bryson's going to help us. 7 times 7?
49.
49. Let's carry the 4 here. 7 times 8 plus 4.
60.
60. All right, we'll subtract, do a little thing here. 15 minus 9, Luciana.
6.
6. And 2 minus nothing. From where we borrowed the 2 minus the 0.
2.
2. And 6 minus 6 is nothing. We'll go ahead and bring down the 1 back to the beginning again, Sam. We're going to use our estimator, which is a 9. How many times does 9 go into 26? How many times does 9 go into 26?
4. No.
What's 4 times 9? 36, not 26. 3. What's 3 times 9, class? 27. That's really close, isn't it? And it's not really a 9. Let's try the 3. You're starting to catch on to that? When it's really close, go ahead and give it a shot, especially if it's a rounded up value. If it's not rounded up, don't try it, but it's rounded up. Let's try a 3 here. Sam, 3 times 7?
3 times 7 is going to be 21.
21. We'll carry the 2. 3 times 8 plus the 2. Class? 3 times 8 plus 2? 26, there we go. 3 times 8 is 24, and that works out evenly for us there. Will all division problems work out evenly? No, but for right now they are. Starting to catch on to the pattern here. Questions on this? All right, let's do one more together, and then yawn for a few of these. Let's look at the next problem here. We've got a 753,651. We're going to divide all of that by an 813. First thing you want to do is figure out what is your estimator. What is the one digit you plan to use? Paige, what should our estimator be in this problem? It's always either going to be the first digit or we might bump it up. Is it first digit or do we need to bump that up?
First digit.
It's first digit. No reason to bump this up. Does everyone see that? Just roll with the 8. If you want to write the 8 up here, you can. I'm lazy. I already can see the 8. Why would I write that? Right? If you bump it up, it makes some sense to write it, but I don't need to write it here. And we're going to ask ourselves, Paige, how many times does 8 go into?
75.
75. Good. How many times does 8 go into 75?
9.
9 times, because 9 times 8, class is?
72.
72. Now watch the digits. 3 digits here, right? Over which of these numbers do I need to put the 9, anyone?
3. 6.
Over the 6, because remember this counts as 1. So this is 1 collectively, 2, 3. So we're actually going to put the 9 here. Does that make sense? How we have to group it together. All right, so we've come up with the 9. Now we're ready to go to our next step, Jalen, which is to?
Which is to multiply.
Multiply. 9 times 3.
27.
Write the 7, carry the 2. 9 times 1 plus 2.
11.
Write the 1, carry the 1. 9 times 8 plus 1.
73.
73. We're going to subtract, do a little borrowing here. And as we do the subtraction, Corey, 16 minus 7. Make sure you're doing this along with me, by the way, working at your seats.
9.
9. 2 minus 1.
1.
5 minus 3.
2.
And 7 minus 7, of course, is nothing. Is that smaller than 813, class? Make sure you compare. But we're ready to bring down. Now we go back to the beginning. We're going to use our estimator, which is just that first digit, the 8, and ask ourselves, how many times, Griffin, does 8 go into?
21.
21. How many times does 8 go into 21?
2.
Just twice. 3 times, not even close. Only twice. So that means we're going to put a 2 right here. And then we'll use our 2 to multiply. Elaine, let's multiply the 2. 2 times 3.
6.
2 times 1.
2.
2 times 8.
16.
We'll do a little bit of borrowing here. 15 minus 6, Ben.
I don't know.
Oh, first and second grade, you're supposed to get these down. Kirsten.
9.
9, there we go. Back to Ben. 8 minus 2.
6.
6, there we go. Do a little borrowing here. 11 minus 6.
5.
5, and of course 1 minus 1 is nothing. Is that smaller than 813, class?
Yes.
But make sure you compare. It is smaller, we're good, so that means we can bring down. Let's bring down the 1. And we ask ourselves, how many times does the 8 go into, Michael? How many times does 8 go into 56? That was what I wanted you to answer. The answer is how many times? 7. No, you didn't. Okay. Let's all of us make sure we understand. I'm not picking on Michael. When I ask a question, don't answer my next question. Answer the question I'm asking now. I asked how many times does 8 go into, and you were supposed to say 56. How many times does it go in? It goes in 7. So I knew when you said 7 what you meant, but just make sure you're answering the question I'm asking so we don't confuse others in the class. All right, so it goes in 7 times into the 56. What are we going to do with that 7, Michael? We're going to multiply it. 7 times 3. Carry the 2. 7 times 1 plus, or 7 times 1 plus 2? 9. And of course 7 times the 8. And it works out beautifully there. Questions on the division? How many say, I think I've got the hang of it now? Some of you probably already had the hang of it before we started. Your turn. Do that next row at your seats. You do the next row of problems at your seats. Either use the first digit, or if you need to bump it up with an estimator, do that. Based on rounding rules. Divide, multiply, subtract, compare, bring down. Where's the worksheet? Oh, just work it right here on the worksheet.
One times 5 go to 14. If you have $14 and you want to buy some $5 items, maybe you want to buy $5 milkshakes for some buddies. How many people can you get milkshakes for if you got 14 bucks?
2.
Only 2. That's your number. And you go from there. Don't do this. It's a waste of your time. We don't want to waste time.
All right, Elaine, sideboard, do the first one on that row. Michael, are you finished with that row? Almost done.
That answer the whole problem.
Okay, you multiply by the whole 54. Just the first problem on the row. So when you multiply, remember, 2 digits. But you've looked at this as collectively 1. This is your second digit, so put the 2 here. And you don't multiply 2 times 5, you actually multiply by the whole 54. So 2 times 4, and then 2 times 5. Then subtract.
There you go. Good. So now, just like you said, how many times does 5 go into 14? Now you're going to say, how many times does 5 go into 41? There we go. So then you put the 8 up there. Elaine, the second row is the one we just did. Yeah, you accidentally went ahead there, but just the second row. Good. Take the second one on that second row on the sideboard for me.
The second one on the second
No, no, him. You're the first one on the second row.
Right, so there's that trial and error element where like, wait, that's too big. It wasn't, you couldn't get that much, right? The greedy sheriff tried to get more money than he could, so we gotta downgrade, don't we? Oh, okay. Same thing I was telling Sam. So right here, you found the 2, but remember, the 2 has to be multiplied by 54, not just 5. So 2 times 4 first, then 2 times 5, 10. And subtract all that. So we're gonna erase that part down there. How many times is 5 go to 41?
I am doing that. I had said 8, so I had to put it up.
Oh, okay, I got you. You're, that's fine. You're allowed to do that. Okay. I thought you were going back to the other thing trying to figure it out, but you got it. Okay. Good. Keep going. Where did 378 come from? I don't see a number up here. What was your number you were using? Is it a 7 maybe?
Yeah.
Wait, make sure you write it. You're not wrong. It is a 378 that you need down there, but it comes from the 7. All right, for sake of time, pencils down. Even though most of you are not finished with the row, that's perfectly fine. I want to look just at the first problem very quickly together. You can look at Elaine's work over there on the sideboard, but for the sake of the video, I'll show it here because something weird happens here that I need to show. Most of us said 5 goes into 14. Go and have a seat, Michael. Thank you. 5 goes into 14, class, how many times? Folks up here, 5 goes into 14 how many times?
Twice.
Twice. 1, 2 digits. Put the 2 right here. Do not multiply 2 times 5. As I said, we'll be doing it. We learned from it. The 2 gets multiplied by the whole 54. Again, if you have to do 54 times 2 up to the side, that's not a sin. I'd rather you say 2 times 4 and 2 times 5.
10.
And do it right there. It just saves time. 9 minus 8,
1.
4 minus nothing.
4.
Is that smaller?
Yes.
Yes, bring down to 0. How many times does 5 go into 41? 8 times. Now watch, you put the 8 and you multiply. 8 times 4, 32. Carry the 3. 8 times 5 plus 3.
43.
43. I can't do that subtraction, can I? Then that's where you erase. And instead of an 8 class, that was too big.
7.
All right, let's try it again. 7 times 4,
28.
28. Careful. 7 times 5 plus 2.
37.
And you know what? It only took one step. We caught our own error. It wasn't really an error, it was just, okay, it didn't work out. But it's a quick catch. Fix it yourself and you move on. Do a little borrowing here, 10 minus 8.
2.
Borrow 10 minus 7.
3.
3. We're going to bring down the 4. How many times does 5 go into 32? 6 times. 6 times 4.
24.
The 2's already up here. 6 times 5 plus 2?
32.
32, and it works out perfectly. All right, so that little glitch of it should be an 8. It makes sense for it to be an 8, and it's just too big. Okay, knock it down to a 7. No big deal. You move on with life. Your answer for the next one, and Michael didn't have time to finish it. Michael, what'd you get for the next answer on that row? 3,059. And then the last answer on the row. Who else finished besides those two? Anyone else able to finish the last problem on the row? All right, let's go back to Michael for the last one on the row. 628 for those who made it there. Real quick, want to look at the next row of problems there that you see. And in fact, actually look in your textbooks if you would at page 5. Look in your textbooks if you would at page 5. And we see those 6 steps of division: estimate, divide, multiply, subtract, compare, bring down. Another thing I want to point out to you though, as you look at page 5, is the decimal. What do you do if there are decimals? I want you to write this in the side margin of your book. You cannot divide by a decimal. Page 5, after the side margin, write it, you cannot divide by a decimal. Write that in the margin of your book. You cannot divide by a decimal. Now, we're not going to work the problem out for sake of time, but you notice on their little blue example problem, they try to divide by a 2.4. You can't do it. You've got to move the decimal over, and if you move it outside, what you do outside, you got to do inside. They had to move their decimal over because you can't divide by a decimal. Look, write this problem in the side margin of the book as well. We're not going to work it out for sake of time, but I want you to see it. 1,115.2 and divide by a 1.36. Just write that problem in the side margin of the book, where I told you to write that you cannot divide by a decimal. We're going to work on this more in our next lesson. There's a decimal there, isn't there? By the way, if there's a decimal here, that's okay, because notice I said you can't divide by a decimal. You can't divide by a decimal. Well, how many times does the decimal have to move to get it out of here, class?
2.
1, 2. And whatever you do outside the house, class, you gotta do inside the house. Well, I don't have 2 places. 1, there's not a second place. You still have to move it. What do you suppose we would fill in the gap with, class?
0.
A 0. And so the decimal would now go there. Just put that much in the side margin of the book so you have it as a little example. There may be times when you move the decimal, you may have to add an extra 0 to do it. We're going to practice with decimal division in our next lesson. Tonight for homework, no division. Okay? We're going to work on division more tomorrow before we start doing any division homework. Tonight's homework, you're going to practice with some of the stuff we've been working on over the past few lessons before today. Homework for this evening is to do page 6 to 7. Page 6 to 7, the practice section. Page 6 to 7, the practice section. Do numbers 24 to 28. Pages 6 to 7, the practice section, 24 to 28, and on page 7, in the homework section. And on page 7 in the homework section, do 15 to 17. So you're doing 24 to 28, and then 15 to 17. Not a lot of problems. I think there's only 9 problems total for homework tonight, and none of them are division. But 24 to 28 in the practice, 15 to 17 in the homework. We'll work on division more tomorrow. Have a wonderful rest of your day. Do not lose that handout. We're going to need it for our lesson tomorrow. Bye-bye.